Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deep programming language series. In today's lesson, we're going to be talking about ref functions, or the ability to turn a reference from a function. Now, we've looked at the ref keyword previously in terms of functions, but we're going to go ahead and do a little recap of that in case you missed that lesson. Otherwise, check out the playlist. And then we'll go ahead and look at this new feature where we're able to return an L value or a ref from a function. So with that said, let's go ahead and dive into this lesson. And as I like to do in these lessons, just to get you in the right page, let's go ahead in the documentation, language reference, and you can go ahead and find functions. And then we're going to want to scroll down here to ref functions. That's what we're going to be looking at today. But before we dive into this feature, which I'll revisit in a moment, I want to go ahead and just give you a quick recap here of what we're going to be looking at here. So let me go ahead and get us to ref functions, just so that's on the help here. What we've looked at so far in this series is something like this, where we have a function here and we've used the ref keyword here to explicitly pass by reference some sort of value. And we'll go ahead and just do this example here. So let's just say a local variable here. And I'll go ahead and call this set value function here. And we'll pass in local variable. And we'll write out the value of our local variable. And within the set value function here, let's just go ahead and set value equal to something like 9999. And then let's go ahead and run this with RDMD. And the result that we're going to get here, because we're passing by reference, is that we are in fact going to modify this variable location. Now, if I get rid of the ref here, this means that, well, this variable is not going to get updated. It's just going to take whatever the default initialized variable is here, which for an integer is 0, because again, variables in D are default initialized. So that's the basic use case that we've seen for ref. Now, of course, with some things like slices, for instance, those are passed by reference. Classes are passed by reference by default. So again, we're keeping in mind some of these details moving forward here. But again, focusing on this keyword here, ref, what happens if we actually want to return a value now? And now we can go ahead and take a look at the documentation here to see what a ref function is. But it's a function that returns by reference instead of by value. So again, what is reference? Well, it's referring to some location in memory. And if you've been following along in this series, we talked about L values, which are locator values or locations in memory, typically being on the left side of the equation here. So for example, if I have int x equals, some value 7, this is the location, or oftentimes we'll say the left-hand side, or abbreviated L value. And what's on the right-hand side, that's at least where the name comes from, is the R value. And this is sort of a temporary value. It's not mapping to a location in memory. Okay, so that's how we can kind of keep track of L values, which are locations, and R values. But again, what a ref function allows us to do is to say, well, I want to return from this function a reference. And if you're coming from C++ or other programming language, what you'll often see is something like this with the ampersand and then the function name and so on here. Okay, so in D we don't have this ampersand that follows here. We use ref here. Okay, so that's the idea. And let's go ahead and just kind of take a look at some of these examples of where we could do this or why we would want to do this. And I think this first example is sort of a nice one here, just showing that if we happen to allocate some value here and want to return, we can actually return that value, because we're dereferencing here with the asterisk from this function here. So let's actually just rewrite this and see how this works and a few of the different features with ref functions. So I can do ref int my function, and then let's go ahead and set auto p, and then I'm allocating on the heap a new integer. And I'm going to just directly initialize it to 2 here. Let's return here. And again, this is sort of the key component here where we're returning the value and actually dereferencing it here. Because when I allocate something on the heap here, and I'll illustrate this in a moment, I am actually allocating. It has an actual location, right? P just happens to be where this is, the pointer to this memory location that's going to be stored. But if I want to actually get that value, which has been initialized to 2, then I have it available here. Okay, so let's go ahead and see how that works. And again, what sort of advantage does this give us? Well, then I can, through this function call, because I'm returning an actual value, or some actual L value here, I can actually assign it here. So I can do this sort of my function like this here. Okay. And let's go ahead and now run this here. And let's just go ahead and write line here. And let's just go ahead and give this a more meaningful name here, value. I suppose that's a little bit more meaningful here in this context, just so we can print things out here and our main here. So we can see the value is 2, okay? So that's what's being returned from this function here. Now you might ask something like, Mike, in this particular case, why are we not just doing something like this here? Int my non-ref function, and I could go ahead and just return the value 2 here, and I would get the same result as far as the function is concerned, right? But here we're going to be making a copy of 2, or whatever this, in this case it is an integer value, and then returning by that copy. So if we've already done some work, and perhaps if we're allocating, and that would be sort of one of the use cases where, if you have a function where you're allocating memory on the heap, then you might consider returning by a reference here, okay? So that's sort of one use case here. You might also have other functions that you write, depending on how you structure it. For instance, you could have something like, get number here. And if this function happens to have a static here, let's just make it an integer. I'll just make it 77, something like that. Then I could actually return a reference here to this number. Again, let's pretend that this is some big computation that had to take place, so I don't want to make a copy or rerun this function or something. So then I could actually just return I here by reference, because I'm referring to this location, and static is allocating one time for this function here. So again, I could do something like int value 2 equals, get number in this way here, okay? And I should be able to run that, and then it works fine. So that's the overall idea of a ref function. Just like we're able to use it in the parameter list when we want to refer to some location in memory. And generally that's a good thing because, well, again, we need a location. It's something that can't be null, for instance. We could do the same thing for our return type here and just return ref. Now, if you go ahead and scroll down a little bit in the documentation, you'll find that you can actually use auto, of course, for your return types, which we covered, but you can also have auto ref functions where this type can be deduced here. So let's go ahead and just adapt our examples here. Now let's just go ahead and let's see if the order matters here. Ref auto. Of course, you can see in the documentation they're doing auto ref. But if we go ahead and run it again, oops, let me go ahead and put the right name here. My function. You can see that it still works here. So I would recommend following this convention. So let's just go ahead and adjust things here. So auto ref, that's how I have seen it more frequently in the documentation. And again, this sample will work here just as expected here. Okay, so that's the idea with ref and returning, and maybe some reasons that you might use it. So again, just try to think about this when you have examples where your function's doing a lot of work, creating or building some object, and then you want to return it, and you don't want to return that copy of the object because the lifetime of this object that you're returning, for instance, is going to exceed how long that function lives, for instance. So that's the general idea. Now I'll just show you something again as I went over from the D example here. Again, just to show that when you're returning by ref here, so let's go ahead and let's create a third example here. And I'm going to call this ref, and let's use auto just to do something different. Bad example here. If you create a local variable here as shown, and I try to return that local variable, well, let's see how far we can get here if I try to run it. Not using it, so it looks like it works here. But now let's try to make a call to bad example. And let's go ahead and run this here. And it looks like it's still able to return here with auto, just looking at this example here. But let's go ahead and do the ref int here. And let's see if the compiler is able to catch here. So it is catching the returning I escapes from a reference to a local variable I here. So the compiler is able to help us out here. I'll have to look into it a little bit with the auto if I do something like this here, why it's allowed or why it's inferring this value. So I would say if you have simple examples here, give the compiler more information so that it can do the sort of escape analysis here to see if there's some local reference, meaning something that's just a temporary value that you're trying to return, because again, this value is going to go away or pop off the stack when we return from this function. So that's the idea with some of the built-in safety in the decompiler, and how to use ref and how not to use it. Because, this is sort of a classic example, returning an address of a local from a function here is a problem. That's sort of a dangling pointer in other languages like C or C++. All right, folks, so with that said, I hope that was a useful introduction. So now you can see how the ref keyword is used as both the parameter type, which we've looked at, as well as the return value, and some use cases where, again, you might want to think about it. Again, think about it in the case that you're doing a lot of work, building up some object, and it's going to live for a long time. So there might be some use cases and design patterns like factories, for instance, where you might want to be able to actually return a reference to some sort of object. Again, you can think about those use cases as they come up. So folks, with that said, I'll go ahead and end the lesson here. If you've been enjoying the series, make sure you subscribe so that you don't miss any lessons. Make sure to check out in the description courses msha.io if you haven't already, so you can find this series and the lessons there as well. And thank you, as always, for your time and attention. We'll see you in the comments section and in the next video below.